Hi everyone, it's Luke, your subject teacher. So let's start our today's class. So today's topic, write down on page number 80. So energy stored in a capacitor. So energy stored in a capacitor. So let me first draw figures. Okay. So these are the capacitor. Okay. Try to understand. First listen carefully. Then only you'll understand. So these are the these are the capacitor. So first what I'll do, let me move or bring a small positive charge from plate 2 to 1. Okay, I'm bringing a small del q positive charge from second plate to first plate. So initially this at this v equals to 0, so how much remains? Minus del q dash. यहाँ के हुन्छ चार्ज माइनस हुन्छ हुँदैन. So work done, we know work done equals to q into v. So q is something, but v equals to 0, so work done is 0. Clear? So next, so this reach over plate 1, so already there is positive charge. Again I am bringing positive small charge from plate 2. Okay, so this remains 2 del q dash. एउटा निकालेपछि के हुन्छ फेरि 2 हुन्छ, isn't it? So but here we have same charge, isn't it? So I'm bringing same charge, so it repulsion, isn't it? So their work has to be done, isn't it? Work has to be done by external field or V. Okay, so likewise if you draw or if you bring or if you move charge, then this charge will get charge, isn't it? So if you say million charge as q dash, then again if you bring del q dash charge, then how much remain? Q dash minus del q dash, isn't it? Yes or no? So this would be minus. So this is your figure 1a in your book. So finally by doing this, this plate will get fully charged and this plate will also get fully charged. Okay, and at this stage you will find uniform electric field also. Clear? So more you goes the next step, more work has to be done, isn't it? So now write down the amount of work done in bringing. So write down the amount of work done in moving, or you can write bringing. Okay, in moving positive del q dash charge from plate 2 to 1 in figure A. 2 to 1 in figure A. So hope you understood this much, isn't it? So how much work is done? So that is your del W equals to work done equals to how much? Product of charge del Q dash into the potential V dash, isn't it? So initially 0, isn't it? So but we need total work done, isn't it? Small work done is this much, so C is equal to how much? Q by V. So V equals to how much? Q by C. So del W equals to how much? In place of V, so del Q dash, Q is same and C remains same, isn't it? Right. So total work done, integrate. So this will gives you W equals to how much? See, 1 by C comes out, left Q dash del Q dash. You know how to integrate this one, isn't it? So if x to the power n dx, if you have to integrate, you have to x plus n plus 1 n plus 1. This is the integration, isn't it? Hope you will not forget this one. You haven't forget this one, isn't it? So W equals to how much? 1 by C. Also we need limit, isn't it? Limit 0 to Q, isn't it? So this Q dash square, isn't it? 1 chain 1 plus 1 2 by 2, so 0 to Q. Clear? So W equals to how much? 1 by 2 C Q square, isn't it? Q dash को जगह में क्या होगा? Q. So this is the work done. Okay. So we know that this work done is stored as a energy in the capacitor. Okay. So write down, this work is stored as a potential energy of a capacitor. Okay. So this work done is stored as potential energy of capacitor. So U, we denote U energy by U equals to how much? This much, half C Q square. Clear? So you can replace this Q. So C is equal to Q by V. So Q equals to how much? CV. So U equals to half C CV square. So U equals to half C C square V square. So C cut. So left half CV square. So this is your energy stored in a capacitor. Now we have a small topic on this. So let write down. मजाले pause गर र सारा okay. So small topic is your energy density of a parallel plate capacitor or electric field. Okay, energy density. So next write down energy density. Mass per unit volume, mass density. So energy per unit volume is your energy density. Energy density of a parallel plate capacitor. They may ask as electric field also. Okay. So we know this one, isn't it? Half CV square. U equals to how much? Half CV square. So we also know that C equals to how much? Epsilon naught A by D, and V equals to how much? E R, isn't it? In place of R we have D. So put here, you will get U cap U. Okay, half epsilon naught A by D into V square. So E square D square. So 1D gone. So U equals to half epsilon naught E. Let me just arrange it. Epsilon naught E square A D. See, AD equals to how much? A into D is your volume. Why? Because area of capacitor and distance, isn't it? This is the distance. So A into D is your volume, isn't it? right? So U equals to energy per unit volume is your energy density. So how much? Half epsilon naught E square. So this is your energy density, energy per unit volume. So like small letter we denote as small letter U. So half epsilon naught E square. So this is your energy density of a parallel plate capacitor, or you can say electric field. So this is your energy density. This is how we denote, small letter. Okay, you can write like this also, U. So hope you got. Okay, now we'll start numerical. Okay, so one more class we need to complete our chapter. Okay, fine, let's, well, so today I'll do one quiz. Okay, but numerical varieties of numericals are there in capacitor. Okay, so varieties of numerical are there. Okay, so first we'll do one figure. Draw this figure, copy my own figure. So let us take numerical write-off. So let us take 6 volt potential, and this is our capacitor. Let's take 2 microfarad, and there is switch, and again there is capacitor. यस्तो छ तिम्रो केमा छ, गाइड बुकहरुमा छ. ओके, so let us take this as 3 microfarad. This is your switch S. Okay, so write down question. पहिला यो लेखे, यो बनाएर मात्रै क्वेशन लेख है, now confuse होला नि. Okay, so question: in the given figure, this is the figure. Okay, initially S is closed, switch के छ, closed. Okay, after S is open and dielectric of 5, this is the value of dielectric, is inserted, so in both C1 and C2, this is C1, this is C2, calculate C, Q. C is your capacitance, Q is a charge, P is your potential. Okay, before and after closing S. So this is our question. So how to solve this one? यो आउँछ. Okay, जसरी आउँछ यो 3 मार्क्स को. ओके, यो सिकेको छ भने थुप्रो कुराहरु के गर्छ, you can solve. So after opening the S switch, dielectric is inserted, isn't it? So लेख, फर्स्टमा लेख, यस्तो बनाएर गर्छु. S closed and S open. So क्लोज छ भने के हुन्छ दुईजनाले v त सेम पाउँछ है नि c1 c2 क्लोज छ भने के हुन्छ c1 equals to how much 2 microfarad equals to how much 2 into micro means 10 to the power minus 6 farad clear अब लेखौ q2 sorry q1 कति हुन्छ चार्ज q equals to cv so 2 into 10 to the power minus 6 into 6 coulomb so how much 12 into 10 to the power minus 6 coulomb now v1 equals to how much 6 volt isn't it 6 volt now यसलाई डिवाइड गरेर 6 volt आइहाल्छ त्यसरी नै c2 हेर c2 कति छ 3 microfarad equals to 3 into 10 to the power minus 6 farad त्यसरी हेर q2 के हुन्छ c into v so 3 into 10 to the power minus 6 into 6 छ नि volt हैन so 18 into 10 to the power minus 6 coulomb अब v निकाला v2 निकाल्दाखेरि के हुन्छ यसले डिवाइड गर सो कति भयो 6 भोल्टै भयो v त सेम छ अब ओपन गरे भने के हुन्छ डाइइलेक्ट्रिक आउँछ के आउँछ डाइइलेक्ट्रिक सो ओपन गर्दा के हुन्छ डाइइलेक्ट्रिक सो c1 ड्याश मा त छ v isn't it so c1 ड्याश कति छ 2 माइक्रोफेराड तर के आउँछ डाइइलेक्ट्रिक कन्स्टेन्ट सो डाइइलेक्ट्रिक कन्स्टेन्ट कति छ 5 into 2 माइक्रोफेराड equals to 10 माइक्रोफेराड अब q1 ड्याश ओपन गरेको सो c into how much 10 into 10 to the power minus 6 into 6 coulomb equals to 60 coulomb अब v1 dash equals to how much यसलाई डिवाइड गरेर 6 volt isn't it तर उतापट्टिको फिगर हेर नेक्स्ट फिगर त्यहाँ चाहिँ के हुन्छ when switch is open v is not equals to 6 volt why again write down मुनिपट्टि c2 dash equals to how much कति छ c2 dash when dielectric is there so 5 into 3 second 3 into 10 to the power minus 6 farad so how much 15 into 10 to the power minus 6 farad अब q हेर चार्ज q2 dash q how much q चाहिँ के हुन्छ into v हुन्छ isn't it yes or no so v छैन so same बस्छ isn't it yes or no q2 dash so 3 into 10 to the power minus 6 into 6 so how much 18 into 10 to the power minus 6 coulomb clear अब हेर v2 dash हेर v2 dash यसलाई डिवाइड गर so 18 6 by 5 volt clear so v is reduced isn't it yes or no charge remains same isn't it अगाडि जति थियो चार्ज त्यति नै सकिन्छ नि 18 18 18 18 coulomb v reduce to understand this one simple example is there practical अब हेर यस्तो किन हुँदैछ भन्दा नि अब यो पाइप छ isn't it so दुईटा ट्याङ्की छ ओके one tank is there another tank is here अब पहिला के छ जाँदै छ नि 6 volt 6 volt छ ओके त्यो डाइइलेक्ट्रिक हालेपछि के भयो 6 volt छ फेरि चार्ज हुँदै जाँदैछ हैन, इजन्ट इट? अब के हुन्छ भने नि यता चाहिँ के हुन्छ, काट्दिएको हुन्छ भोल्ट। त के भयो, अगाडि डाइइलेक्ट्रिक थिएन, यति थियो, इजन्ट इट? अब क्यापेसिटेन्स बढ्छ, सो के हुन्छ, यसको लेभल के हुन्छ, घट्छ। सो भोल्टेज कति भयो, घटेन। So that's it for today. So tomorrow one class we need one class, then we'll wind up this chapter. Okay, so that's it for today.